Thank you, John. So, hello everyone. It's a real honor for us to speak here. And as John said, our talk is about hyper-pragmatic approach to tests. So, let's talk about tests. We know that they are important. They are the simplest way, the cheapest way to define and verify contracts for our code, and contracts are essential for project maintainability and viability. And most of us write tests, a lot of them. But we know that some tests are useful and some tests are not. So the question is, which tests are good and which are bad? And surprisingly, it's not so easy to give a formal answer to this question. But we may define several criteria for bad tests. So we may say that slow tests are bad. Unstable tests which fail randomly are bad. Non-viable tests which do not survive refactorings are bad. Demanding tests which require complex preconditions to be met, external services up and running, fixtures loaded into databases and so on are bad. And incomprehensible tests which signal about a problem but do not help us to localize it are bad. So we may say, still informally, that we spend more resources to write and maintain bad tests when the value we bring to us. And the question is, how may we make our tests better? So let's start by ditching classic unit functional integration trinity and let's introduce some new terminology. So we may say that every test is either black box or white box. Black box tests, we check just interfaces. We don't know anything about implementations behind these interfaces, so we maintain encapsulation. And white box tests, we may know about implementations. We may check and verify some internal state, and we may even tamper with that internal state. We may also say that every test is either atomic, group, or communication. So atomic tests are tests which check just one unsplittable software component. Group tests, we check groups of software components or aggregates. And communication tests, we communicate with outer world like databases, API providers, etc., etc. This simple taxonomy is sufficient for our today's purpose. But I want to say that you may feel free to introduce your own taxonomies. Sometimes they may be very beneficial for you. They may help you to understand what you do better. And we also have our own multidimensional test taxonomy. There is a link on the screen, you may read about it. It may be really interesting for you. So, why did we do it? Why did we introduce our own test taxonomy? What's wrong with existing one? With one, it gives us a very valuable guideline. It allows us to estimate potential value of a test even before we actually write it. And according to our experience, the best tests are black box tests with atomic or group isolation level. And actually it makes sense because such tests are expected to be fast and refactoring resilient. But there is one issue. In real projects, most of the tests fall under communication category, or what people usually call them integration tests. Why? Because engineers, they want to test the whole thing under real circumstances, and it's hard to separate components, and we may have not enough time to do that, and so on and so on. So, in fact, we may think about replacing our integration components with dummies, or people also call them fakes, in-memory implementations, or mocks. This way, we may turn a communication test into a group one or atomic one. But I have to say that this statement applies to black box tests only. So, in case we do it and in case we execute the same test scenario twice with both production and dummy implementations of its integration components, it may be beneficial for us because at one hand we may test business logic quickly without any potential interference, but at the other hand we still would be able to verify business logic behavior under real circumstances with real integration components. We call it dual test tactic, and it's good for us and good for you because it enforces us to follow Liskov substitution principle, and it enforces us to design better. So, I may say that refactorings are essential for long-term health of our projects, and black box tests may enable refactorings, and dual test tactic may drastically reduce the price of your refactorings. Before we continue, I want to share several ideas about dual test tactics. So, first idea is instead of failing communication tests when where preconditions are not met, it's better to skip them. So, in that case, a new developer which came to your team may just clone your repository, type sbt test in his console, and got half of the tests green and our half skipped. And he may start, or she, may start immediately playing with actual business logic without setting up environments. When it's a very good idea to evoke automatic mocks because they prevent encapsulation and they are not refactoring resilient, and usually they require heavy, mostly runtime machinery to work. So it's cheaper to just write dummies. And also, please never bring heavy dependencies like Kafka or Cassandra or whatever else into your class path. And never run such things during your tests, because this is the best way to make your test suites and whole your project unmaintainable. So, so far so good, but there is one issue with dual test tactic. It's very easy to deal with dummy implementations, but once we start working with production ones, things start getting interesting. So we have to care about resource acquisition and cleanups, we have to care about test with speed, execution speed, we have to take care of memorization and resource allocation, potential interference, and so on and so on. So let's have a closer look. So here is a diagram representing a sequence of steps which needs to be performed to run a test suite in an imaginary project consisting of two services, user service and account service, each correspondingly depending on user repo and accounts repo, and the test suite itself, it consists of two actual tests. Such diagrams, we call them project networks. Actually, mathematicians call them project networks. And arrows here we mean should be done after. So, for example, actions like actions make user repo and accounts repo they are independent and may be executed in parallel. So this looks simple, but once we start looking at the diagram for a real test case, it doesn't look good anymore because now we have three phases: setup one, execution one, and cleanup or tear down one, and we have many aspects to take care of. So we have to take special care of actions order. We have to think how to avoid unnecessary job, how to memorize resources. We have to take care of resource allocation and deallocation, especially in situations when something failed. We still want to be able to shut down or deallocate our resources in correct order. We may wish to add other aspects like Docker container support, and we may want to wait until our containers become available, and so on and so on. So integration points, we stack together, and they actually make this problem notably hard. And in case you try to wire a variable context manually, you may figure out that your code suffers from combinatoric explosion of possible code paths. And the cake pattern doesn't make much difference, and the DI frameworks may fail. So unfortunately, it's hard to set up variable contexts. So in fact, dual test tactic, while it looks beneficial, it may be very pricey under usual circumstances. And the question is, can we make it cheap? And the answer is yes. What is our goal? We want to write our abstract test suites as functions, taking all their dependencies as arguments. And we want to be able to easily mix our abstract test suites with their environment definitions. So this is an almost working example of a code we want to write. And we made the thing which makes it possible. It's named DIStage. It's a dependency injection mechanism for Scala, which actually lacks negative traits of your typical DI thingy. And it has many unique properties, and it's blazing fast. It may give you sub-millisecond timings on hot JVM. You may actually call it a module system for Scala with automatic garbage collecting solver. I'll explain it a little bit later. Why DIStage is good for you? Because it supports functional programming. It can wire resources, effects, DO environments, cakes, and whatever you want. It's transparent and predictable. It first plans the job when does it. And it allows you to test your outcomes without actual effect execution. And you may have compile time checks and compile time tests. And there is no dependency on Scala Reflect nor Java Reflection. And Scala.js support is coming. In fact, we have implemented our own lightweight symbolic computational simulator of Scala typer. There is a link on the screen. You may read about it. It may be an interesting read for many people. DIStage is non-invasive. So you can add it to your project, keeping your business logic intact, and you may remove it later in case you don't like it. And actually, it's not an ad hoc thingy. It has a strong theory behind, so strong that we were able to replicate essential functionality of Docker Compose as a simple extension for DIStage, just 300 lines of code. And actually, it can do more than Docker Compose. It can await until your test containers get up and running and ready to accept your requests. So now Kai is going to show you all the goodies which you may get by employing DIStage in your technology stack. And there is a link on screen with full source code of the example he is going to show. So give us a couple of seconds to switch. Can you guys hear me?
Dual test tactic and the framework in question, they are not something theoretical. This is actually something we use to write real-world software every day. So let me show you how this works with a real example. The app we're going to test consists of 3 components. The first component is a ladder repository. It allows the user to submit a score and get a list of scores back. It has two implementations, one dummy and one Postgres implementation for the real database. Second component is the profiles repository. It allows user to upload a profile and allows to retrieve the user profile. And it also has a dummy implementation and Postgres implementation. And the third component is the ranking service. It allows you to get a ranked profile for a user that combines data from the user profile with the rank and their score in the ladder. It just combines the outputs from the other two services, so it only has one implementation. Not just it's a pure business logic. It does not have an associated table in Postgres. So let's take a look at how a typical test for this application will look like. Now, this is an atomic test for a single component. First, we generate a user ID and a score. We submit the score, and then we assert that in the list of scores, the score that we submitted is present. And the rest of the tests, they generally follow the same pattern. You just insert and check the results. So I just run the tests and see what happens. Yeah, so we've ran two sets of test sets, one for the Postgres implementations and one for the dummy implementations. The test output is a little weird because DIStage-Testkit is based on top of Scala test, but Scala test does not have the tools required to make the test output look really good. On the other hand, it's fine, and I think it's an okay trade-off for the IntelliJ support and IntelliSense we get for free, which is from based on Scala test. So the Postgres tests, they are communication tests. They depend on external component. A component that runs in my Docker, and let's see what will happen if I destroy the Docker daemon and run the tests again. Yeah, so the communication tests were skipped because their precondition was not met. Postgres was not up, so they were not even attempted. They were not canceled or interrupted. They were never even attempted. They fell under precondition. So we can see that we can reuse the same test code and run it but against two different implementations. How do we do that? Let's check how we wire our components. How does that all work? First, where do we get our components from? Here we specify that we want to load the components from the Leaderbird plugins package. Let's check what's there. So a plugin contains a set of modules that contain bindings, declarations. We declare what interfaces we want to wire and what implementations we want from them. We can wire from pure functional resources or effects also. Some of these modules are tagged with a choice on the configuration axis. This module provides repo dummy implementations. And repo is defined as an axis with two choices, production or dummy. So repos may be either production or dummy repos. So for our dummy repositories, we wire two dummy implementations, large and fuzzy. And for our production repository, we wire the two Postgres implementations and also the associated machinery that we need, such as the Doobie transactor. Yeah, so you may notice that we still have communication tests. Despite saying they're less valuable, we still must have them because they're testing very valuable system properties. For example, we cannot perform any upgrades if we don't even know if the next version of an external dependency will work with our software. We must still have these tests. So if we must have them, we can at least make them faster and better. And one thing that makes integration tests slower a lot of the time is components that take a lot of time to start up. For example, this component. In the acquire action of the Postgres ladder resource, it will create the table it needs because all the subsequent functions returned here, they do not make sense without the actual ladder table on the external database. We must create our table, otherwise the component is broken. But on the other hand, we don't want to recreate that table for every single test all the time. Just sending a query to the database will be slow by itself. So we declare that these two components will be memoized. They will be instantiated just once and shared through the entire, throughout the entire test suite. So we may run the tests again, and we may check for the log line saying that we create a table. Okay, so there are only two matches for creating tables. So the table was created, so each table was created only once. Once for the profile table, once for the ladder table. If we remove the memorization designation, let's look what happens then. So creating. So we in fact created the ladder table 5 times and the profile table 4 times. So that's a lot of times for creating the tables all over again. So this can really speed up tests that have any kind of heavy components. Or for example, you may, if you're testing Cassandra, you may designate a key space as memoized. You may create a new key space for your test suite when the test suite starts. And when the test suite ends, the key space will be deallocated, dropped on the database as per your resource acquire actions. So, one more thing about activations. So they are not only for the tests. You may actually run your application itself with dummy implementations, for example. Here we specify that the main dummy launcher will use the dummy implementations and the prod launcher will use production implementations. And we never actually write a main method because we may have multiple main methods. Again, we discovered them from the plugins, and every component that inherits from the role service is going to define a purely functional main method that inherits our source. For example, this component is wired here. We may have multiple of such roles in one single launcher, and for example, if we run them with dummies, we can have a perfect simulation of our entire product running in one process with one command, launching instantly, and like consuming 300 megabytes of heap space, because all of it is dummy. And this is great, for example, if you want to provide a good development environment for your front-end engineers without having to actually have a remote environment. You may launch all your dummy services locally and develop locally. So let's try to launch the main dummy. Check it will launch. We have an HTTPS API. We don't have any create messages, so it is in fact a dummy. Let's try to launch the production main. And it's refused to launch because its precondition was not met. It also depends on Postgres. But it will not use the test Postgres because we're not using the DIStage-Testkit Docker support inside our main scope. So we'll have to launch a new container. Try again. Okay, so we have the API, and we can test it by running the curl. Yeah, so we've got rank 1, score 100 in the leaderboard we just received. Yeah, so you may have noticed that the main function also refused to start same as the Postgres test were skipped before. This actually uses the exact same mechanism. Let's check where we define the precondition that actually causes it to fail. So here is where we create the transactor that we use, the DB transactor. We just import DB Hickory CATS resource with our CATS integration layer. But we also add another clause, the integration check. This will run before any attempt to acquire a resource or even any attempt to create anything is made, just to check if it makes sense to proceed at all. So in this case, we'll just probe the port instantly to check if it's available. And if it's not, then the startup will not proceed, or the test will be skipped. And also, you may have noticed that we had to create a Docker for the main prod, but we didn't have to create any Dockers for the tests. And let's see why. Let's just remove our Dockers and see what happens when we launch the tests again. It takes quite a bit of time. And why is that? Because we're trying to check if the Postgres image was actually updated, and there will be a new Docker container, and it's surely available now, just for the tests. Why does that happen? How does that happen? We've actually included some overrides here for the bindings that were provided, that were loaded from the plugin package. We also override them with these definitions. Here we declare that we want a Postgres Docker container to be made. And here we replace the Postgres port configuration that is usually read from config with the port of a running Docker instance. That this will also cause the instance, the Docker instance, to be launched to actually get that port. And we include the machine required to create the Dockers, and we add a configuration for the Docker client. And in this case, we specify that we allow reuse. And what does that mean is that in this case, we will not close the container, then actually it's still alive. So the next time we run our tests, it's going to happen faster, and that's because there is no pools. We didn't try to create a new Docker image. Yeah, we use the same Docker compose Docker container running, and we still have just one container. If we are running CI builds, for example, we may turn this off, and then the Docker container will be deallocated at the end of the test. And note that for memorization, there is no global variables are used, no singletons or no objects. It's all purely functional, happening in one flow. And so there's been a little demonstration of the capabilities of DIStage-Testkit. I hope you liked it. So I'll give the word back to Pavel Shirshov.
Thank you. So, let me switch back. 1 second. Okay. So, that was intense, and we still have plenty of time. I wanna say a couple of things about. I wanna say something about things I didn't mention. So the first thing is most of the job is done at compile time, and compile time verification is possible. Second thing is there is one important feature which he didn't show, but as per we have enough time. Let me demonstrate you something. Just hold on. Let me mirror the screen. 1 second. Better now. So, presentation mode, what is it? Yes. Okay, I guess it's better without it. So let's look again at our test suite. So here in this particular test, you can see what the dependencies are declared here in the lambda signature, right? But in the following one, there is no such a declaration. Why so? Because we leveraged zero environments to get rid of these noisy and repetitive things. So, in fact, an environment required for this particular test, it can be inferred through contravariant environment, we may use DIStage to wire such environments. Let me switch back to the main thing. How do I turn off? Here. So, how is it all possible? How DIStage works? Actually, it performs optimal ahead of time planning. It takes your wirings, turns them into a directed acyclic graph. When it removes all the unreachable elements in that graph, so performs garbage collection actually. When it executes linearizes that graph using topological sort and executes it, right? So again, it doesn't do any unnecessary job. And another thing which Kai mentioned is it allows you to apply role-based approach. So instead of making microservices or monoliths, you may represent your product components as roles. You may create just a single Docker image or a single distribution with all the roles available, and you may run them all together or independently as you want. So you may have all the benefits of microservice approach while keeping all the benefits of monolith one. Which is very important, it allows you to perform perfect simulations of your product environments on very weak machines and do it quickly. So, as a conclusion, I would say that DIStage framework is the most productive way to write maintainable and pure functional applications with Zio and with actually any other monad. DIStage-Testkit is the best way to make your test performant and reliable. you may try to start using it in your projects. It's already adopted by several different companies and tested by 2 years of actual production use under relatively high load. For most people it will be high load. So there are several links to the slides, to our GitHub. You may follow us on Twitter. Thank you for listening. Thank you for watching. Now it's time for your questions, in case you have any.